Xavier Bignalet, who is the Security Product Manager at Microchip Technology. His presentation is titled Secure Key Provisioning, How to Overcome Its Logistical Challenges. Xavier, over to you.
Thank you, Mick. We're going to start the session with this sentence that keys are everything in security. Keys is all about security is all about keys. So why the keys are so important in security? That's because if you start to possess the key, if you're in the possession of the key, you can impersonate the device, and critical transaction can then be impersonated. So there are two theorems here. One from Kirchhoff that says that the crypto system should be secure if everything about the system except the key is public knowledge. And Claude Shannon is telling us the enemy knows the system. So if you couple both, start to see the importance of keys in security. Historically, what has happened across various market segments, if you look at the world of servers using TPM, Trusted Platform Modules, computers doing the same, payments or isolating the keys in a smart card, which inherently inside you have a little secure element, the SIM card in the phone, the printer cartridge, all of them, what they have in common is they use a secure key storage technology to isolate the keys physically, create that air gap between keys and software, firmware, users, contract manufacturer, and so forth. There is a trend here. It's a remaining challenge that is personalization. Each of those systems have to be personalized. And here comes the main problem is the notion of customization in the supply chain ecosystem of security. So the challenge, like I mentioned, is the notion of personalization. What you need to do is you need to configure security according to the threat model that has been defined. And then you need to customize the system because each system will have its unique set of keys for each single product. So with this notion of customization, how do you scale customization across your supply chain all across the globe during development and during production in the supply chain? If we focus first on the personalization during the development phase here, there are a couple of hurdles that developers will get through. First of all, they're going to need expert knowledge, either by hiring or contracting. Then once you have the experts, there's a complex suite of huge variety of tools that developers are dealing with. And then if you look at security as a whole, it's a multi-layered ecosystem with a variety of providers. So how to choose a given provider for given security features. Then you have that notion of configuration following the threat model to make sure it fits the use case that you've identified. And there's also a notion of support finding skilled local support is another challenge during the development. Now, if we switch to the manufacturing phase, what's happening there? As you bring customization into a supply chain, it will add time and cost, right? That's inherent. There is also operations such as a key ceremony or secret exchange, depending on where we come from in the industry, those terms are being used. And this operation of key ceremony triggers a provisioning process. Provisioning, it's the operation of loading securely, binding keys with a product and a customer, and loading those keys into a system, those keys that are unique. And then you have that notion of manufacturing the device in a secure supply chain. So now the supply chain has to be equipped with hardware security module, ideally in your product lines. How many product lines do you have? Where are they in the world? What is the throughput that you can execute with such equipment? On what is the impact of those equipments in your supply chain in terms of operation? And then at the end, you often have a custom part number, right? So in today's market, for the world of secure element, for example, you have a threshold that's around the 100,000 unit threshold, give or take. So that means if you have a project that runs below that threshold, it's going to be hard to access those security technology. And then think about the contract manufacturers, right? They have you start to hand them off your keys. How do you negotiate the next contract? You keep them, you do a price negotiation with them, or you want to move to another contract manufacturer. What's happening to this whole exercise of handing off the keys to your system? That becomes quite a problem because now you have a very custom logistic process with that one CM. So it's really customization becomes the enemy of scale there. And then let's complexify the whole ecosystem and look at everything from the semiconductor to the distribution, the contract manufacturer, the OEM, the product itself when it's released and it lands into the hand of the user. What's happening to those keys all across the chain? And all of that is not just for 1, 5, or 10, major brands and major product. We live into an extremely fragmented market within the world of IoT that's composed of small size, mid size, and large size customers. Third parties are being involved. What's happening to those keys and how this customization can live in this business ecosystem? So there needs some improvements. We need to improve first the onboarding, the user onboarding, to get the project moving smoothly. We need to reduce the friction due to the personalization, and we need to make secure key storage available to the masses. So Microchip has announced the Microchip Trust platform for the Cryto-Authentication. So let's look at what it is. It's a service combined with hardware, code examples, and a provisioning service that I'm mentioning here in front of us. It's composed in a 3-tier service. The first service is the Trust&GO. Second one is TrustFLEX. The third one is Trust Custom. Trust&GO is basically a pre-configured and pre-provisioned secure element. Here we're talking about the ATEC 608 that comes with default certificates that are already in the device. You don't have to buy them. You don't have to load them. You buy it and you have that black box that doesn't move and comes with that set of credentials. It's a very cost-efficient solution when you think a certificate authority would charge tens, if not hundreds of thousands just to get a certificate there. Some thousands of dollars. Up in the portfolio, we have the TrustFLEX, which can be achieve the same level of use cases as the Trust&GO, so device-to-network authentication for TLS and network, LoRa network, but also many more use cases, and we're going to talk about it in a minute. This TrustFLEX is not locked. You can replace the default credentials by your own credentials too. And the Trust Custom is a fully customizable secure element that you can pretty much support most of the authentication use cases known in the market. Now, the interesting thing here is the MOQ, the minimum orderable quantity. We're going down from 100,000 units a year threshold down to 10 units, including the provisioning for Trust&GO. We're down to 2,000 units, including provisioning for TrustFLEX, and down to 4,000 units, including provisioning again for the Trust Custom. So what we wanted to do was to offer a simpler onboarding with the tool. First of all, remember we need to reduce the friction on the onboarding. So we have a use case tool called the Trust Platform Design Suite, where you can configure and select. You can select the use case that you want, whether it's network authentication, accessory authentications, and so forth. Or everything is in that software, the Trust Platform Design Suite software. Behind what's happening, you have Python executable tutorials that will help you to test your use case between your laptop and your secure element to make sure everything works. Then we move from the Python environment to C code environment and we offer a turnkey C code project for each of the use cases. And finally, we also offer that a secret exchange template file that already offer a lot of the work, the configuration work needed to start that secret exchange. It really turns months into minutes of development, and no exaggeration. We've had that product for now about a year, And we've seen the speed of execution has been improving by quite a lot on the customer side. So the Trust Platform Design Suite comes with a suite of hardware tools. Obviously, there's Trust Platform USB kit is the flagship, and then all the other 3 boards or accessories to that main boards. We have an add-on board with more Trust&GO, TrustFLEX, Trust Custom devices. You have socket options for SOIC and UDFN packages too that you can plug onto this Trust Platform USB kit. When I mentioned the complete projects, we have turnkey code example to show you how to connect a microcontroller, a Wi-Fi, and a secure element to implement mutual authentication to AWS IoT, Google Cloud Platform, Microsoft Azure, LoRa networks. We also have third parties example with Wolf SSL, Armband TLS. Arduino has been leveraging our Trust&GO technology. So at the end of the day, what you have is a wiki user manual on GitHub, turnkey code example on GitHub, and of course, the hardware that goes with it. If we go into the Trust&GO now, like I mentioned before, it's a pre-provisioned secure element. It's kind of a black box solution that would handle 2 main use cases: IP-based cloud authentication on TLS networks for AWS IoT, Google Cloud Platform, Microsoft IoT. But really, those are examples. The Trust&GO can connect to any TLS-based private network or public network. As long as you have a TLS handshake, the technology will work. And then with LoRaWAN networks, also pre-provisioned for the things industry and activity joint servers, but it's technically capable to connect to any joint server as long as the shared keys are exchanged correctly with the joint server providers. You can have more information about the 2 options on microchip.com/trust&go. And let's take a look at how the onboarding looks like. So we have a customer that wants to order Trust&GO parts. Microchip will manufacture it. But we don't just give the part, right? So once the part is ordered and paid for, we issue a manifest that basically represents the list of public credentials associated to the amount of devices ordered. The customer will download it from our e-commerce stores and upload it into the cloud platform of its choice. All the 3 cloud platforms have all the API necessary to receive a manifest file. And that's it. Now we've established a secure, trusted mutual authentication between an IoT device and a cloud providers. Moving on to the TrustFLEX here. It's the same as Trust&GO with more features. So you can do those 2 use cases, but you can also you can also change the default certificates that are loaded in the Trust&GO by your own certificate and have your custom certificate authentication. You can implement JSON Web Token authentication. You can implement secure boots, OTA verification, firmware IP protection. All of those 3 use cases of firmware verification, really. Message authentication. You can rotate a private key. You can do public key attestation that's not mentioned here. IO protection key is a binding between the microcontroller and the secure element in a unique fashion. So all of that is possible with the TrustFLEX, and the configuration is already done. It's just, the device is just waiting for the credentials to be loaded using Microchip provisioning service. More information again here at microchip.com/TrustFLEX, and we can take you in a much deeper details on the solution. So what is the onboarding looking like? If you're a customer, you want to order a TrustFLEX device, you need to start working with the Trust Platform Design Suite software and select the use cases, generate that secret exchange using the secret exchange template that we are providing with it. You will provide across encrypted channels, of course, to Microchip e-commerce account, the encrypted file that will have all necessary information, and then Microchip manufacture the secure element there. Very similarly, and that works also for participating distribution partners. Once the order has been executed, we ship the devices, and we also issue this manifest that will be uploaded later on by the customer into the third-party cloud ecosystem. So at the end, very similarly, you establish a secure, trusted mutual authentication that's completely cloud agnostic, that's completely microcontroller, microprocessor core agnostic, and that can work with any PKI providers. So as takeaway, if you look at the Trust platform, it offers predefined use cases to ease the onboarding during the development. Something we offer simple tool sets to accelerate your development cycles. You can also now leverage e-commerce stores to receive the manifest file that will have the public credentials instead of facing the friction of customization in your supply chain. We made sure this technology is a fit for the mass market with low minimum orderable quantity, including provisioning service and micro certificates. And finally, our technology remains architecture agnostic with any cloud, any PKI, any controller, and any connectivity. Want to thank you for your attention. And Mike, do you want to take it away?